So here, but we know that the nth term of the series is given by Tn. It is the general term. Tn is equals to a plus n minus 1 into d. But whereas at a equals 2, so as per the series we got a as 2 and as well as d as 1. So here by substituting these two values, a as 2 and as well as d is equals to 1, by replacing these two values in the gen term, that is the general term of the arithmetic progression, so that implies, so here Tn is equals to a replaced by means of 2 plus n is unknown minus 1 into d by means of 1. So that implies 2 plus n minus 1 into 1 is of n minus 1 again. Then the next logical step will be of n is of positive, I want to write it in the beginning. Then now 2 is of positive and the 1 is of negative. These two are of constants. We can simplify further. So plus into minus is of minus. Let us subtract greater minus least, that is 2 minus 1 is of 1. To assess the sign of this 1, so here we have to see the greater among 2 and 1. 2 is greater than 1, therefore 2 sign is of positive. Therefore 1 assess the sign of positive. So in this manner I got the nth term of the second terms of the series by means of n plus 1. So here as per the problem, so here according to problem that is given, the series is of, so here 1 into 2 plus 2 into 3 plus 3 into 4 plus dash dash. Here the nth term lies, then now the series continues up to infinite number of terms, whereas here we said that, so first terms of the series are of 1, 2, 3 and so on, and the second terms of the series are of 2, 3 and 4. So here on the whole we wrote it as the term number 1, 1 into 2 as the term number 1. The second term will be obtained by means of 2 into 3. So here third term by means of 3 into 4, and the nth term will be of, that is the first terms Tn into second terms Tn, that is the nth term. So first terms Tn, this is the first terms, nth term into, so here this Tn indicates the second terms of the series nth term. So here we have to multiply the first term's nth term and as well as the second term's nth term in order to get the Tn, the capital Tn, the nth term of the given series. So here capital Tn is equals to, hence capital Tn, that is the nth term of the series, will be given by means of nth term of first terms of series into, so here nth term of second terms of series. So here as per the problem we got the first term's nth term is of, so here in this manner we got the first term's nth term. First term's nth term as n and the second term's nth term as n plus 1. So here thereby, so here first term's nth term, the capital Tn will be given by means of capital Tn. So that implies the first term's nth term will be given by means of n into the second term's nth term will be given by means of n plus 1. Then now that implies, so here in order to get the capital Tn, that is the nth term of the given series, each and every term in the bracket must be multiplied by means of n. So n must be multiplied with n first of all and then with 1. So now that implies n into n is of n square plus n into 1 is of n. So therefore we got the capital Tn, the nth term, as n square plus n. But here as per the problem we have to find out the sum of n terms. So in order to find the sum of n terms, we have to apply sigma to the nth term. So here in order to find the sum to n terms, of the given series, so here we must apply sigma. So here, which is nothing but called the sigma, which is in other words called the summation, sigma to the nth term, that is capital Tn. So here that implies, so here we have to find out the sigma of capital Tn, but capital Tn is equals to n square plus n within the bracket. So we have to apply sigma to this nth term. So but nth term is given by means of n square plus n. So we are going to apply sigma to this bracket, that is n square plus n. By writing individually, sigma must be applied to each and every term, sigma with n square plus sigma with n. So here that implies sigma n square plus sigma n. So that implies, so we got the summation, sum of n terms as, sum of n terms we can write it by means of s of n is equals to sigma n square plus sigma n, whereas Sn indicates the sum of n terms of the given series. So here S of n is nothing but the sum to n terms of given sequence or the series. Then now by applying this sigma to each and every term, so the next logical step will be of, so that implies we know sigma n square is equals to n into n plus 1 into 2n plus 1 overall divided by 6 plus sigma n as n into n plus 1 overall divided by 2. So here we have utilized two conditions. So we got this logical step by using since. So here sigma n square as n into n plus 1 into 2n plus 1 overall divided by 6 as the first condition. Then as the second condition, sigma n is given by means of n into n plus 1 overall divided by 2. So here I have utilized these two conditions in order to get this logical step. Then now that implies n into n plus 1 into 2n plus 1 overall divided by 6 can be treated as 2 into 3. So here instead of 6 I am going to write it as 2 into 3 plus n into n plus 1 overall divided by 2 with its coefficient as 1. 1 into n plus 1 is of the same n into n plus 1, that is divided by 2. Then now in the next logical step, so that implies n into n plus 1 overall divided by 2 from the first term and n into n plus 1 by 2 n into n plus 1 overall divided by 2 in the second term. I want to take it as common. So here n into n plus 1 overall divided by 2 is taken out as common. N taken out as common and n plus 1, this bracket is also taken out as common, and the denominator 2 is also taken out as common. Whereas in the numerator, so just 2n plus 1 is left over. Overall divided by, when 2 is taken out as common in the denominator, just 3 is left over in the denominator place, plus. So here n into n plus 1 by 2. So here n into n plus 1 by 2 is totally taken out as common, just plus 1 is left over in the numerator. Then now, the next logical step will be of, that implies n into n plus 1 overall divided by 2. Then now here, so here I want to take the LCM as 3. The denominator will be of 1 here. Then now 3 and 1 the LCM is of 3. When this LCM is divided by means of this 3, that is the denominator, it is of 3, number of times is of 1. So here numerator, that is 2n plus 1, must be multiplied with 3 number of times, 3 ones is of 3. So here plus numerator 1 is written as it is. When this LCM 3 is divided by means of this denominator 1, so here 3 by 1 will give us 3, or in other words 1 into 1 number of times. So here 1 3s is of 3, 1 3s is of 3. So the next logical step will be of, that implies n into n plus 1 into 2n plus 1, 1s is of 2n plus 1 plus 3 ones is of 3 overall divided by, so it is of n into n plus 1 by 2, then overall divided by, say here 3. Then now the next logical step will be of, so that implies n into n plus 1 into 2n, 1 and 3 are of constant terms, plus of plus is plus, let us add up, 1 plus 3 is of 4, that is of plus 4, because 3 is greater than 1, 3 sign is of positive, it asserts the sign of positive, overall divided by 2 into 3. So we can write it as 2 into 3 in the denominator. Then the next logical step will be of S of n, the sum of n terms of the given series is given by means of n into n plus 1 into 2n plus 4 divided by 2 into 3. So that implies, that is S of n, sum of n terms is given by means of n into n plus 1 into 2n plus 4, 2n plus 4 overall divided by 2 into 3. 2n plus 4 overall divided by 2 into 3, whereas in the second bracket 2 is the first term, and whereas 4 can be split as 2 into 2. So we can take 2 as common here, then the next logical step will be given by means of, so that implies, so n into n plus 1 into, so among these two terms, when 2 is taken out as common, when 2 taken out as common, just n is left over within the bracket plus 2 number of times. So here 2 into 2, 2 into 2 is of 4. So overall divided by, so here 2 into 3 again, whereas here there is of into symbol. So here we can simplify further. So here 2 ones in the numerator and 2 ones in the denominator. Then the next logical step will be of, so that implies n into n plus 1 into n plus 2 overall divided by just 3. It is nothing but the sum of n terms of the given series. So here hence sum of n terms of the given series is S of n is equals to n into n plus 1 into n plus 2 overall divided by 3 is the required solution.